Good morning, everybody. So let us start our lecture today. Oh, sorry, maybe I forgot to upload the last lecture video, but I will do that today. Okay, today is October 7th, so let us see our schedule. Okay, so according to our schedule, this week we will finish QE. So we started early this week. Our last lecture was about QE. And let us proceed on today. Okay, by the way, I published quiz test 1 grade. Please review your grade, and then if you find something wrong from our side, please email me. Okay, please email me with your claim and with your justification, and I will review it. And you have to submit it submit your claim by this week, by this weekend. After this weekend, I will not accept any more claim for the test 1. So by this weekend, please review your test 1 grade, and if you have any issue, then please let me know. Okay. Sorry. And also you see that quiz 3 and assignment 4 is also up. These are also up, so please start this, okay, and complete this as soon as possible. These are this weekend. Okay. So now let us quickly recap what we were discussing in our last lecture. So a QE is a FIFO, first in, first out type data structure. FIFO means, for instance, in a ticket in daily life, we stand for ticket or in cashier counter or in line to get in a bus. So we follow QE. Okay. As we remember that in a stack, one side is open and another side is closed. Only one side is open. So all input and output operation in a stack, it happens in one way. So the top element, the element that comes first, it goes all the way last in stack. Okay, and the last element that comes last, that stays on the top, so it goes out first. Okay, so but so this is for stack, but QE is opposite. It's completely opposite of stack. So it's both sides are open. So the element that comes first goes first. So that it calls first in, first out. That ins first, that out first also. This is why it is called first in, first out, or FIFO type data structure. So QE stack has many implication in programming, but QE has limited implication. But one of the implication is that to check palindromic string, whether a string is equal to its reverse string. For instance, here if we see pop, if it is a string, right? Pop is a string. So if we say POP, and in reverse order, if we read from bottom to left to right to left, so then still it will be pop, POP. So this is a palindromic string, but there are some numbers that are also palindromic numbers that are called, for instance, the number 101. It is palindromic, right? If you read from left to right or right to left, this is same. Similarly, the number 11, the number 111, the number 11, like these same numbers, or like numbers 222, All of these are palindromic numbers. But there are, for large sequence, maybe you will see there will be palindromic numbers, maybe 1, 2, 3, 2, 1. This is also a palindromic number. Okay, so if you any order, if you get one number at a time, you will get same sequence. Okay, this is an implication of QE. So, for instance, this is a string. If we do not consider uppercase or uppercase or lowercase letters, if we convert wall in uppercase or wall in lowercase, then we will see that the string is palindromic. There are some languages like Arabic language, it is read from right to left. So in that case, for this kind of palindromic string, if you even read from left to right or right to left, it will mean something. Okay. So in our last lecture, we discussed with this program. So I shared this program with you, right? Palindromic program. Let me see. Okay, this one in the last lecture I shared with you this program. This is a very simple, straightforward program. Okay, it uses stack and QE. Okay, why do we need to use both stack and QE for this program? Give me 1 second, please. Let me get that. Okay, think about you have a stack. Okay, and you have a QE here. This is QE and this is stack. So here, if you you get some numbers, for instance, 1, 2, 3, 2, 1. Okay, and then if you push these numbers in a QE, so the number will go from this way, right? First number will go 1, then second number 2. So then one number will be pushing front. So for instance, the first number will go 1 over here, the second number will 2 over here, third number here, then fourth number 2, and the last number 1. So think about the like these are okay in cell, individual cell. Okay. Now I have another stack. Okay. Now if we remove one element from QE and put in stack, then what will happen? The first number, this number will go to the stack all the way here. 1. The second number will go to the stack and it will be here. And third number will go to the stack. It will be here. And fourth number 2 will be here. The last number 1 will be here. Okay. Now you copied your elements, your data from your queue to stack. Now if you do a, so these are push, okay, and in terms of QE, it is called, this is called NQE. Input are called NQE. These are called NQE. ENQE. And these are called DQE. Okay. Now, if you do a pop operations, do some pop operations. Pop means, we know that, removing an element from a stack. So this is QE. This is stack. So removing an element from a stack so that it goes only from top, right? So then first one, the letter it will go 1, and the second letter it will go 2, and third one it will be 3, fourth one it will be 1, 2, and then fifth one it will be 1. Can you give me 1 second, please? Sorry, my computer is disturbing for okay. So now if we see that, if we do again push operation, pop operations, then we will get the same number. Okay, so now the thing is that the concept is that if we have a number, any number, and if we push in a QE, if we put in a QE, enter in a QE, and then from the QE data we transfer to a stack, and from the stack, if we get it out, and if we get the same number, then the numbers are palindromic. Right? But if they are different, then Okay, so this is the concept. So this is why they used both QE and stack over here. Okay, so please practice this program. Okay, now, does anyone has any question about this?
No, I don't.
Oh,
No, sir.
okay, thank you. Let me. Okay. Now, in our last lecture, we saw stack implementation. Okay, I gave you homework to practice this car wash simulation, this class program. Okay, so the program is here. Inside program is here. Just copy and paste this code from here to in your program, and you see that what you will see, this program does not have any main method. So what you need to do, you need to write your main method. In that main method, so what they put here, they put the entire code that as a method. The car wash simulate method. So they put as a method. You can write this in main method and call outside of main method and call this inside of main method, then you will get this result. So without main method, the program cannot be run. Okay, so please do not mislead it with that program. Do not try to run it unless you have a main method. Just copy and code this paste this code in a file and try to do it. And if you face any issue, oh, I think the authors, they have given code over here. So maybe you can go and then you can copy it. Let's see. Oh. Oh, it has main method also. So they call this. Okay, car wash.c. Let me quickly copy it. CPP. Example 1, CPP. Okay. Okay. So this program will not run automatically because we need to add this, right? So first of all, we need to add washing.h header file. Okay. This is the car method. This is the this method, and they are calling this method over here. So this method is declaration over here. So let me put it here. Then it will be easy. Okay. As I said, you have to write this method in the file, and then you need to call this method within main method using some by providing some data. Okay. Okay. So now we need to add washing.h header files. Let me see in the book. Book has washing.h header file. This is washing.cpp, and I believe this is washing.h. Yeah, this is washing.h header file. So quickly wait. Add a file shing.h and paste it because it does not come, as I said, it does not come all. So we need to see what did not came in. So this boolean source, did it come 0.05? If you copy and if you see the wall selected, then it's came. Okay, and then fine, start washing. Let me see if it came here. Start washing. Okay. Now we need washing.cpp file. It will not travel. Oh, I have it here. Washing.cpp. I can get it from here. Okay. And now let us see washing.wasing washing.h. File is company. Okay. Line number 7, washing.cpp. Washing.cpp. What is wrong here? Let me refresh it. Okay, after refresh it is gone. Errors are gone. Maybe let me try it. So in washing.h, in main.cpp, unknown type figure to file from figure 8.6.
I think it's in the washing.h file, not the main.cpp.
What is that? What is that?
From what I can see, it looks like it's in the washing.h file, line 14, figure 8.6. So it's just trying to read that as a programming language. Line 14, I think, can just be commented out.
Oh, okay.
And 18 looks like. Or I don't know what's that. I don't know what 14 through 18 is going to do.
Okay. What is still this error for? I think, let me see. This should be this is header file, so this should not be like this. This should be commented.
Yeah, see, all that's commented out in the book.
Yeah. That should be commented out. So okay, now let us see if there's any other reload. Okay, continue should not be here. Double average constant. So what would be here? Something it did not came up here. average. This is a method. Averager. Okay, I think what we can do, I can do all commented out until we do not need until this. Okay. Okay. These are the commented. So instead of this comment, I could say it could be this. So it will ensure that all will be commented out from starting to. What is showing this? Okay, now it is gone. So until this is commented out, and then it start header file start with if endef. Okay, so it is header file. So it is the header file method declaration in CPP file. Okay, and then this is the main file. In main, it has a car or simulation simulate method function. Okay, and then this function. So as we know that if we declare this function after we use it, then we just need to if we define a function, this function, after we use it, then in C++ we just need to give a header over here, prototype over here, header line over here, the declaration over here. So that means that this program will be using or maybe using this function. So it says this function will take an unsigned integer in integer argument that was time and double type, arrival probability, and unsigned integer total time. So these are the values they put. So this one integer number, and this one is a double number. So in order to be a double, either one need to be double, either numerator or denominator. Okay, and this is integer number, and you could do it integer also with the unsigned integer. So unsigned means a number is unsigned. You understand what is an unsigned number? Do you understand what is an unsigned number? Can anyone please tell me what is an unsigned number in mathematics?
Like non-negative numbers?
Yes. Unsigned numbers are always positive number. But is that if we write a number that is signed, that means a number, if a number is only if we say 5, that we understand is plus 5, positive 5, right? So the giving positive number is optional. And since it is optional, we usually do not do it, not use it. But if number is negative, like negative 6, then we must give the sign first. Okay, so this is sign number. So all of these are sign number. This is sign and this is sign number. These are sign number. Sign number. But if I say only 6, or only 5, these are unsigned number and always positive number. Positive. So the integer type has range from 0 to 65535, and the left side negative 65536, right? So this is the range of integer number. So then if we say unsigned, that means all is from this side. Unsigned, it takes all is from this side. Okay, and this part is signed. So unsigned is always positive part. Okay. Okay, so now the program is over here. I'm giving you a link. Okay, so please practice it. Okay. Oh, well, bad. Oh, that. Okay, I'm giving you one, and I will give you one more. Okay. Now let us go to the next program. So in our last lecture, we discussed that a queue can be implemented in two ways. One, using an array, like in array style. Okay, another is using linked list type. So in our last lecture, we discussed that an array style implementation. So you know that an array, for each element, there is a corresponding index number, right? For an array, every element has an index number. So we go through array elements through index. And for instance, if you have data like this in a queue, the front side, these are character type data. You know, with a single quote means these are character type. It contains only one character. A character type cannot contain more than one character. Okay. So every element in an array, we know that every element has index. The first element had index 0 and then 1, 2, 3, 4, like this way. Okay, and if we implement a QE like an array type, then array, in an array, we know the first elements has the index 0, right? In an array, just recall, in an array, the first element has index 0, and the last, what is the index of the last element in an array?
1 less than length.
Length, yeah. Length minus 1. Yeah. So this is an array. So this element is first element, and its index is index 1, so index 0 with index 0, and this is the last element, index length L-1, length -1. Okay, but in a QE, what we have either first or last, or we say call this is the front or rear. So in a QE, we call the first element is called first. You can say first, or usually it's called front, or you can say top, whatever you say. But in array in a QE, the terminology is front. Okay, and the last element is terminology is rear. Okay, or it can be said in some book, you can say tail, or you can say last element, or you can say bottom. Bottom element, whatever you say. Okay, so here the matching is that the first element or the top is with index 0, and the last elements with index length -1, right? So now if we, in our array type implementation, if we move this out, okay, for instance, A was the top element, if we move this out and if we move this out, okay? So in an array, it does not, a static array, okay, we are discussing about static array, it does not remove the memory space. Okay, it's just remove the element with maybe null or whatever empty character we are putting. Okay, and then so if you move the first element, then your top first element will not be here. First will go to the next one, and again you move the next one, remove the next one. Okay, the top will be this one, right? So for instance, this is after removing first two elements, your first element's index is 2, not 0. And then there is the third element, is the first element. Third element in the array is the corresponding top element or first element of the QE. So then in case of array type implementation, what do you need to do? As soon as we remove an item from a QE, you also need to update index, because initially we put first element with index 0, and then if we move an element from here, so then from this index will be changed. It was initially 0, then it will no longer be 0 if you move over here. If you, then it will be 1. If we remove another element, then it will be 2. So here, this is why after removing 2 elements, it is 2. Okay. This is for the case of we call removal. That is in case with QE, it is called DQ operation. Okay. Similarly, for NQ operation or insert operation, initially, for instance, we have only element C, or here this element ABC. Actually, it was ABC. Don't see here. ABC. Okay, now if we insert, so this was initially C was the last element. So no matter how length, what is the length of this array? This was your last element. Now if we add one more element over here, so that element will go to the next, and this will be your bottom. Your last will be increased by 1. Okay, and also if you input another element, then your last index will be increased by another 1. So this is why initially it was last index 2, and then after 2 insertion, it will last index will going to be increased 2 times. And you see that after 2, this was initially your first element, and then after 2 removal, DQ operation, the first index become 2. Okay, what do we see that from here? There is a match, is that for both removal or insertion, either it's a deletion or insertion in an array type QE, for both cases, index, first index and last index increase. Okay, all I said previously it was 0, then 2, and then 2, and then 4. Right. So this increment happened due to deletion left side, and right side increment happened due to insertion. Okay, so in an array type implementation, for adding element, we need in a QE, we need to increment last index. Okay, for insertion, last index, and for deletion, we need to increment first index. Do you understand this? Okay, do you understand this? Does anyone has any question?
Not right now.
Okay, that's good. That means we will remember that whenever we insert an element, we will increase the last index or bottom index. Okay, and when we remove an element, what we will do? We will increase the first index. Okay, so then if you remember these simple steps, then you will be able to understand the array implementation. Okay. Okay. So now this is the program. Okay, in the book, this is an old style book. They make it clumsy. They put it QE template class, and then they converted it to a class template to a class, and this is more complicated. So brother, I will give you a simple example instead of this. Okay, so now let us go to our program that in our last lecture we discussed. Okay, so this is a QE. So instead of front, the first they've said front, okay? So then rear is, these are integer type, okay? And then capacity for a QE initially. So this is QE, and then it takes integer type, argument, and then initialize it as a q equal to new integer type, and here is the destructor, and here is enq operation. So whatever we learn for enq operation, what we will do, it will increase the rear, right? So every time there is an element insert in the data, in the QE, it will increase the rear. And for the enq operation, it will q dq. True. Okay. What they did different implementation. They could do easily. They could increase the front. Okay, what they said, they shifted it. So what they did over here, instead that's a different program. So what did they do over here? So there are both ways we can do. Actually, let me explain this one. So this is a QE. For say this is maybe 0. This is array implementation 0, 1, 2, 3, 4. This is array implementation, and over here, so they kept the top, or this is a front over here is fixed, okay? And then whenever they're removing an element A, B, C, D, for instance, these are our element, they're removing that element. There are two ways you can remove. You can increase. The book says that you can increase the front index by 1, but here this implementation is another alternative implementation. You can push the element. So you can push the element. Whatever you say pushing, by pushing element, you don't need to remove. That means by pushing this one, so then B, how do we push this one? So B will go over here, B will replace A, and B will be replaced by C, C will be replaced by D, D will be replaced by E, okay? And then initially, this was our rear. So rear, so this element will be gone, so rear will be decreased by 1. So this is why they decrease the rear. This is another alternative implementation. So there are multiple ways they can do that. Okay, so here this is say for I equal to 1 to rear minus 1. Okay, I plus plus. If say qi equal to qi plus 1, that is qi initially I equal to 0 equal to qi plus 1. This is another implementation for dq. Okay, that means it's just it does not remove, actually it replace. Let me tell you again one more time if you need help. We have a QE like this. Like whatever QE we have, okay. For instance, this we have our data A, B, C, D, E, okay, and this is our top or front. In the book, this program says front, okay. So let us say front, and this program is says rear or bottom. So removing an element, whatever, how do you remove an element? Okay, so that means removing means the B, first one, second one will go over here, then third one will go over here, next one will pushing backward. Okay, so that means in that case, and rear will be moved over here. So initially it's index 0, 1, 2, 3, 4. Index was 4 rear, and this type's index will be 4 minus 1, 3. So every time, how long it will go? Starting from index to the last index minus 1. Last index minus 1 equal to 4 minus 1, 3. You cannot go last element. Okay, you must have last element minus 1, because what you are doing over here, you are moving one element from the last element from the to the backward. So remember that this thing, do not do mistake over here. Okay, so that means you cannot go that there is no element over here. It is out of this Q scope. So you cannot do this way, right? There is no value over here. There is no value over here. This is out of control. You don't have access. This Q does not have access to this one. So do not be misled. So this one, that means this one will be rear plus 1. This is rear plus 1. Rear plus 1. So rear, so we need to go rear one element behind. We will one step behind. Okay, so this is the pushing over here. So then ultimately what will be, this element will be replaced by the next element. So this will be top element. So this is another implementation. So book does not say this way. This is different. Okay. Does anyone has any question about this? Okay. The last one we will discuss the linked list implementation. Okay. Now before that, let us get the attendance if I forget. So let us take the attendance first. So 7 October 7 today. And Jason is here.
Yes, I'm here.
Okay, thank you, Jason.
Thank you.
Matthew here. Daniel. Myers. Antonio. Antonio. Meyer.
Yeah, Antonio's here too.
Okay. Jasmine.
Here.
Clayton. Elisa. Taylor.
Here.
Yep, I'm here.
Lisa here. Taylor here.
Yes.
Ernest here.
Yes, I'm here.
Angel. Jaden.
Here.
Cody. Isaiah. Jimmy.
Here.
Savvy.
Here.
Loyal. Dave.
Lau's here. Lau Lucky.
Karen. Mikhail.
Here.
Jess. James.
Here.
Brandon.
I'm here.
Noah. Noah. Alan. Kenya. Kenny, are you here? Jimmy. Livia.
I'm here.
Jesus. Cameron. Sebastian.
Here.
Alice. Justin. Daniel. Andrew.
There.
Nicholas.
I'm here.
Jessica. Okay. Now, let us go to the last program. QA linked list implementation, this one. Okay, maybe I can improve this program better way, not instead of stack. We can use class. I will try today. Let us see. Okay. So this program is the linked list implementation. So what is meant by linked list implementation? So linked list, you know that we know that linked list is the foundation of linked list, stack, and queue. And then all other advanced data structure like binary search tree, at the graph, we will see at the other kind of trees, and we'll see at the end of this semester. So in a linked list, as we know that there is a node. This is the main ingredient of a linked list, stack, and queue. Okay, so this is the node. What is a node? A node, so is declared as a class. It can be declared as a class, or C++ has structure data type. So this is why it is implemented structure, but it can be implemented with class. I will go with the class example also. So a node in an object is a class. So a node class is it defines the type or prototype of node objects, right? A class defines the prototype of object. So over here, so a node object data. It can be any type of data. It can be integer data. It can be string, any data kind of data. It can hold multiple data, but for simplicity, they start with one single data in integer. Maybe the ID number. And it holds also another address of the next node. This is why they implemented with pointer. Okay. So, and then this node also will hold data, maybe ID, and it holds next address. Okay. And similarly, this node will hold data and next ID. So in a linked list type implementation, this dynamic implementation, it does not need to assign memory space previously, like unlike in the array implementation, we put a fixed size array. We start with a fixed size array, right? But here we don't need to get size. The size, as long as an element is inserted over here, that size will be incremented automatically. And as soon as you delete or remove an element, the size will be decreased automatically. Okay, so and so removal or insertion, okay, it also free up or assigns memory dynamically, so there is no loss of memory. So as you need, as much as you need, that much you use. That is the concept of dynamic data structure, right? So this program is a sample program. It implements NQ. So what is NQ operation? For instance, here NQ operation, we have a value, for instance, and we are taking the value over here. And then what is there? So if rear equal to null, that it checks. That means if, for instance, if for an empty linked list, okay, it creates a node, okay, and it creates a node, and the node has the, so for a QE, we maintain two things, right? One is top or front, okay. One is front, front, another is rear. So for an empty linked list, front equal to rear equal to null. For an empty linked list, okay. So that means it checks if rear equal to null. That is empty linked list, empty QE. There is nothing in it. So whatever element we will push, that will be our first element, right? Whatever we element or node we put, that will be also our first element. That will be also our front element, and also will be our bottom element. Understand? So this is why, and for instance, we push one element over here. Okay, and then then it will also be ready for the next node. So rear equal to rear dot next equal to null. So that means it will make say rear dot say this was rear, that was null, but it's a rear. So in Java and C, other language format we say dot, and here in C++ we say arrow operator. It means next. It's less than minus sign and then followed by a greater than sign. So whenever we do handwriting, we give like this arrow sign. But in computer, you cannot give this sign. So whatever you give is minus sign followed by an greater than sign without any space in between. This is what it looks like. So then array dot next will be rear dot next will be. So what is next? Next is also another null, another node. So this is next. Okay. Okay, this is next. It is also next is also another node. So this will have null. Okay, and then data. So data of rear. Okay, data of rear. Okay, so data of rear. So then data of rear will be the value. This is rear, and this value will come over here. That will value. Sorry, whatever value you put over here, maybe 1, 2, or 3, whatever you say, that value will come over here. Okay, and then in that case, there is only one. So there is only one element. So here, so this will be your front. Front will be, what was rear initially? Yeah, rear was this one. Initially rear as this one. So this will be front. This will be your rear. So front will be updated by rear, and also rear will go here. Rear, what is rear? Rear is getting this data. Initially rear got this data. This it gets the memory location is allocated in memory. Okay, and this is the rear, and this is so rear is allocated fast. So initially, before this insertion, rear was null. But whenever we got an element, that is the first element, we get some memory space for rear. Whenever, for instance, you can remember this way, like a baby is not born yet. Okay, so whenever a baby is born, a baby gets its position in this earth, right? So that is the new baby born style here. So in C++, this memory allot method. Java does not need this. Okay, and it allocates memory for the new born rear, and it will what does this do? You can write this fast, and this, let's try with this shipping swapping these two values over here. What do you see? It should not be a problem, but here you see that as soon as it born, it gets a new value. It also make the position ready for the next element. So without doing this statement, what does this statement do? It makes the next element ready. So for the insertion, another insertion, it can be happen without any issue. So this is this statement that ensures that. Okay. Unless, because this will be a, we will see that in our next week we will start recursion method. So it works as recursively. That means it will be calling itself again and again. So this is why same time. So the thing, next time it makes ready for the next element to be inserted. So this is one, and this one here, if already there are some elements exist in this, so that element usually it is pulled in a temporary location. That temporary memory is swapped and put over here. So this one, so we are out of time today, and what sorry, I wanted to I wanted to convert this program from stack to a class. I will do that, but let me rename this program. So linked list implementation with stack. Example 1 CPP. Okay. I want to do another program. I'm sorry. Q implementation, like QUE, UE implementation with class on CPP QM implementation with in linked list format. Okay. Implementation in linked list format. Okay, I'm out of time. I will write this program and then I will share with you this link. Okay, so then you will practice it. This is simple. There will be some changes over here. Let me remove this. QE implementation in, this is array. Oh, no. In linked list format with structure. So practice this one and another one is that with class. Okay, although it is empty now, I will fix it, I will complete it, and I will share the link with you, okay? Okay, and then I'll make the changes and then I will. What do we need to do? We need to make, instead of structs, we need to make it a class. And then we need to change some, make some changes over here. Okay. Then we don't need to struct over here. And then we need another class. It is called class QE. Maybe we can say QE. QE. That class will take, will go all the way and here it's called end of. And we need to change some this. Actually, the class. This is the node, the need structs. We need struct. Okay, I will make this, fix this, and then I will share this with you. Okay. But when I fix it, I will send you a message. Okay.
Got it. Thank you.
Thank you, everybody.
Thank you.
Thanks.
Have a good one.
Yeah, please do not forget to complete the quiz 3 and assignment, next assignment, okay? And you know that I sent an announcement that now you can see our GTS in face-to-face meeting. So in D12, I announced their schedule. Okay, so please follow and get help. Okay, thank you.
Thank you.
Thank you.
Bye.